Hi everyone, today we'll be doing a lesson on imaginary numbers. When people are on the SAT and they see imaginary numbers, they tend to panic and get scared because it sounds scary, something you're unfamiliar with. But you don't have to be scared, it's not that difficult. It's pretty basic. There's only a few things you need to know. So I guess the definition of the imaginary number thing we're talking about is I squared equals to -1. Or I is just like a letter used to like represent imaginary numbers, okay? And I is therefore root -1. This is the main thing, and that's basically all you need to know. So why do we use imaginary numbers? I didn't do any research on the history of this, but if I had to guess, probably has to do with how if every single time people came across a negative number under square root and they just deemed it, impossible, there would be so many math questions that you can't really solve. So I bet somewhere along the line in history, someone was like, let's create these imaginary numbers, which don't make sense with like the rules that we know, which is you can't have a negative number under square root. But I is this like number that someone created so that you can now do that. Yay. So imaginary numbers are usually written in the form of a complex number. This is called a complex number, where A is the real part and B, I, is the imaginary part. So for example, it might look something like, 7 minus 3i, where you would say that 7 is the imaginary part and 3i is the, 7 is the real part and 3i is the imaginary part. I would say this is all you need to know in terms of like the concepts. So let's move on to a possible question. This is from a past SAT test as well. I don't remember which one. But see here, they're asking you to give it in like this complex number form, I guess. In the question above, A and B are real numbers. So the reason why they say real numbers for B as well is because B is like a constant, I is the part that's imaginary. B is like a real number that's multiplied to the imaginary, and therefore now BI together is imaginary. Does that make sense? Okay. And I equals to root -1. So they even tell you what I is in case you forget, okay? So what is the value of A? If you see this, you might get scared because it seems a bit complicated, but you would just use the rules that you already know and you're familiar with to solve this like you would solve any other question. Like if you were asked to solve this, for example, instead, all you would do is FOIL and you would get an answer. Well, now instead of that, you can kind of just think of it as 15 minus 4i, 6 minus 3i. I would suggest, so some people would like to substitute I as root -1 right here, like as soon as I get to this step where I'm about to multiply. Personally, I think that's a bit excessive because there's a lot of writing root -1s. I'm going to keep it as I until I get to the very last step, or you'll see what I mean in a second. I don't necessarily have to take it out. Actually, in this question, I might not need to do that at all. We'll see. So how do we multiply two things like this? We're going to use the FOIL method that we covered in the previous video. So first, 15 times 6, outer, 15 times 6, outer is 15 times -3i, inner is -4i times 6, and last is -4i times -3i, and that, that is equal to A plus BI. So let's simplify what we can. What is 15 times 6? That's 90. And then 15 times -3i, -45i, -4 times 6, -24i, -4i times -3i. Okay, let's be careful with this one. There are two negatives, so that's going to turn into a positive. 4 times 3 is 12. I times I is I squared. Okay, so you get this, A plus BI. Now, simplify a little bit more. You have 90 minus 69i plus 12i squared equals to A plus BI. At this point, right, it doesn't look like what we have here. We have this I squared. Now we can substitute this I squared for -1 like we talked about earlier, or if you want to just use information given here, we'll substitute the I for root -1 first. So 90 minus 69I plus 12 over root -1 squared equals to A plus BI. Oh, I'm running out of space. That gives you 90 minus 69I minus 12, because the squared and the square root cancel, so you get a negative and you get that A plus BI. Okay, I'm gonna bring this over here. Let's go back up. So you get 90 minus 12, which is 78, and then you get -69, so -69. So yeah, the value of A is going to be 78, where this is supposed to be A plus BI. Got it? Does that make sense? Usually questions with relating imaginary numbers tend not to be that complicated, so when you see it, don't panic. Just do every other step that you're familiar with and you already know how to do, and you should get to an answer. Okay, bye.